everybody to our database and memory office hours session. Today we're going to talk about in-memory hybrid scans, which is another one of our 21C features. We've slowly been making it through our 21C features along with some of the other topics. My name's Andy Rivenes. I'm a product manager for database and memory. And today we have a special guest, Tech, who's one of our development managers and one of the development, I would say, gurus that has helped with quite a few of our database and memory features. And so I thought it would be fun to invite him as our expert on in-memory hybrid scans so that you can't stump me, you'll have to try to stump him. So with that, our landing page, I always like to remind you guys that we do have all of our previous sessions on the landing page if you just scroll down. And then we have some resources, and I'll probably talk about the blog and our resources page that's associated with the blog. So if you want to get more information, try Live Labs, take a look at our YouTube channel, go look at any of an easy link for our previous AskTOM sessions. And then, of course, documentation and the in-memory advisor. And so I kind of put some of the main links there. And so there's resources if you want to go back and explore more about database and memory. And I think that's enough of that. So let's see, I've learned a new trick, I think. We'll see. So there, Tech, is that the presentation there?
You can see it on the screen.
Great. So I usually wind up stopping share and hunting around for it. I've learned that there's a button there to do an easy switch. So with that, again, my Twitter handle, if you want to follow me on Twitter, and email address if you have questions after the session and on any topic with database and memory, feel free to email me if you don't find the answer somewhere else. And again, we'll have this, excuse me, this session recorded, and so you can go back and take a look at it. We will do and we're just going to describe a little bit about database and memory or in-memory hybrid scans. We will do a short demo, so is kind of what we always like to try to do as a topic and show it in action. And then obviously we'll answer any of your other database and memory questions in addition to if you have any on in-memory hybrid scans. Actually, I put queries there. I probably should have put scans, but queries, it works as well. And just type your questions into the chat or the Q&A, and we'll pick up on either one. But if you do have questions, I'm more than happy to answer any of your questions. Hopefully we have the answer, and if not, we'll find it for you. So with that, I think we can go ahead and get started. Did you have anything you wanted to add, Tech? I'm going to keep putting you on the spot. So
no, this is I'm happy to join you, Andy. This is an exciting new feature, and yeah, let's get started.
All right. So kind of Tech actually mentioned this to me yesterday when we were looking over the slides, and the motivation for in-memory hybrid scans really has to do with what if you don't have enough memory. One of the strategies I talk about in our best practices sessions that we do, and even in our introductory sessions when I go to conferences and talk to customers, is what do you do if you don't have enough memory? So that's kind of the in-memory part of database and memory. You're going to populate objects in the column store, and not everybody's running around with terabytes of memory in their database servers. So one of the strategies has been to exclude columns. Actually, so we do support compression, and I usually talk about that first, but since we're focused on in-memory hybrid scans, the motivation for doing this or having this feature is really that customers will exclude columns from being populated in the column store when they don't typically do analytic queries against them. In other words, those columns can just be taking up space that could be better used for other objects. And so what people will do very often is partially populate in the sense that you can exclude columns, and we'll demonstrate it actually, but you can exclude columns from being populated. The drawback for that, though, I mean, the benefit is you use less space, especially for objects or columns like delivery note or things that might not be accessed as part of analytic queries, but also might be fairly large and take up quite a bit of space. And so but the disadvantage of that is that if you then query on that object in your SQL query and you have one of the columns that you've excluded in the query, then we'll have to go against the row store for that object in order to access it prior to 21C. So the purpose of the in-memory hybrid scans feature is to allow us to still be able to run the query against the column store and then go pick up any projection. And that's kind of the key here, is that any projection columns or columns that are in the select list from the row store after the query's run. So the benefit of this is it gives still very fast performance, much faster than if we had to get all of the data from the row store, and still be able to have columns excluded to kind of reduce that memory footprint in the column store. So you kind of get the best of both worlds there, even if you wind up inadvertently, or maybe you have a class of queries that do access columns that you've excluded, and you know this, but you're willing to pay the slight penalty for the gain in memory. So that's kind of the lead-in, if you will, to the in-memory hybrid scans feature that's in 21C. And I'm sure somebody is going to ask, so I'm just going to say that no, it's not going to get backported to 19C. This is one of those features that will stay in 21C. We've backported things like the base level feature, cell memory, and so but 19C is a long-term release, so we're not going to try to pull all sorts of features back. So that's 21C, and then going forward, 23C looks to be our next long-term release, so obviously it'll be there as well. Looks like we had a question. It's interesting. The question is, I notice if I only populate certain columns and decide to turn off in memory, the data in the entire table gets truncated. So yeah, I'm gonna assume truncated caught me a little off guard there, because I was afraid you were saying it's truncated from the row store. But in the column store, if you alter a table to be no in memory, then yes, the table will be removed from in memory in its entirety. And then if you do an alter table in memory, which we'll do, and then if you were to do another alter table in memory and exclude columns separately, what happens is we actually will unpopulate the table, if you will, and repopulate it. And that may be what you're trying to ask. I'm not absolutely positive. Hopefully that answers your question. If not, then put another question there, maybe clarify what you're referring to. Hopefully that answers those questions. So you have two there. I think they're the same. Look like to be the same question. I notice that I only copy certain columns. Yeah, so hopefully that answers your question, and we'll go ahead and continue on, maybe, by clicking the right place. There we go. So in-memory hybrid scans, 21C feature, and again, the point is that if you exclude columns, we can still access the column store, whereas prior to 21C, we can't. We're going to access that object from the row store. And I'm going to actually, show you that in the demo. And so this is kind of the slide, and I've showed this slide in 21C new features, one of the previous AskTOM sessions. And so this is just kind of, again, reiterating the purpose of the feature, or actually how it works, purpose being saving space, and then how it works being able to still access that data in the column store for things like where clause predicates, joins, and then only having to, if the columns that are in the select portion of the SQL statement have been excluded, being able to go pick those up from the row store after the fact, rather than having to run entirely from the row store. So it looks like we might have, and actually Tech, you can feel free to answer. You are, great, awesome. hard to do two things at once. So text answering the, I think, reiterating or following up on the question of, I notice if I only populate certain columns, that's the same question. So Tech will go ahead and answer that. So if you do it in the Q&A, it's a little easier for us to track the questions and answers. But either way, we're more than happy to answer all of your questions. So what else do I have? I have so for the demonstration, what we're going to do is, this will be the query I use for each of them. It'll be a fairly simple query to make the example simple. But what the key will be is, notice the LO revenue column. So this is, again, our star schema benchmark. We have the line order table that we've used in almost all of our examples. And so the LO revenue column, initially, the whole table will be populated, and I'll show you that. And one of the key things is how much space that takes, just with the default compression level. And then, because obviously compression is another way for you to save space in the column store, and we've gone over that several times. And the only thing I'm going to add is, remember that, compression isn't necessarily a bad thing. You can still get very good performance, and much better performance than if you don't populate the objects in the column store. And that, again, maximizing your in-memory footprint. But if you do decide to exclude columns, and we're going to exclude not only the LO revenue column, but several of the other columns in the line order table to show the space savings that you could achieve and still be able to run queries. However, notice in the where clause, we have LO order date, quantity, and ship mode. Those can't be excluded. If you exclude those, then we will go after the row store like the old pre-21C behavior. So as we go through the demo, I'll point that out. But this is the query we'll use. And then we'll go ahead and show this in a demo, but since I post the slides on our AskTOM Office Hours, actually in GitHub, so you can go back and look at them, but for the session, if you don't want to look at the whole video, I wanted to point out that what we'll be doing is populating the entire table, and then I'll be excluding a bunch of those columns, and this is the syntax. And notice that we're going to save quite a bit of space. So I've kind of cheated or teased a little bit of the demo, but I wanted to include these in the slides so that it's clear how this all works. And so I'm actually just going to skip this, since this is all in the demo, and go ahead and just get started. And again, it looks like we're getting some questions. Tech, I'm going to go ahead and just repeat the question, even though you're typing the answer. You might want to just go ahead at this point and we'll just do this verbally. But so the question is, while testing the in-memory option in one of dev Exadata databases and executing an aggregation type query on one column, we saw the performance is slower as compared to exactly the same non-in-memory object. But then when we turned off cell offloading, the in-memory object query performed faster. So does it mean its in-memory database option is not much effective on Exadata machines? And the answer is no. Actually, on Exadata, database memory is much better, because not only do we have memory, we have flash. But when I see these kind of questions, first thing that jumps out at me, we talked to a customer yesterday actually, is that you might want to go back and look at some of our AskTOM sessions and our blogs on rack databases. So my first concern, since you're running Exadata, which typically means rack or multi-instance databases, was how is the object distributed in the column store? Since you're going to have more than one instance, that's our scale out for database and memory. You may have column stores across multiple instances. Now I want to get back to the demo, but I'll answer this, and maybe this is what Tech's also putting in the answer, is that don't forget that in order for us to access that data in multiple column stores or across the instances, we have to use parallel query, because we're not going to ship IMCUs across the interconnect like we do cache fusion with database blocks in the row store. So that might be one possibility. Of course, and again, we've talked about this in the past, in past sessions, if you want to go back and look. The best way to identify what's going on is with a SQL Monitor or a SQL Monitor active report, which shows not only the execution plan, but also where time was spent during the execution. And even if that time was spent, say, in memory, since you could hover over the activity bar or even other areas. And so I can't answer, maybe Tech can, but I can't answer this question for sure, but I can give you hints of what you need to look at or how you might be able to determine the answer to your question. So hopefully that helps.
I completely agree. I mean, this typically boils down to parallelism. And even if you simplify the test case to just a single instance, what we need to be aware of is with Exadata, you have a ton of implicit parallelism on the storage cells.
That's true. Yes.
While within memory, you are reliant on your degree of parallelism for PQ to control how many parallel threads on a DB side. So that mismatch between parallelism is normally what explains this observation. So.
Yeah, and it's highlighted nicely in a SQL Monitor Actor report, because not only does it give you all that information, but it also automatically ties in all of the parallelism if you do wind up going with parallel query, which you probably will need to. And then, of course, Exadata, because database and memory and Oracle database have so many features, you can use the for service command, which we talked about, for distribution, to maybe tie your objects to single instances. And then, of course, you have the duplicate option in Exadata, where you could duplicate the objects across different nodes if you're unwilling or unable to use parallelism in your application. The one that comes to mind that I usually bring up is the eBusiness Suite, which doesn't allow inter-instance parallelism. So the solution there is either tying to a service for node affinity or duplicating if you're on Exadata. So it's actually, I hate to say it's a complicated answer. It's not necessarily really complicated, pretty easy to understand, but there are lots of options that you can apply features with Oracle database, which database and memory then leverages to architect your application so that you do get great performance. Because Exadata, screaming fast, very fast CPUs, interconnects fast, and then you have the flash, smart flash cache, which we support columnar formats in smart flash cache, as well as being in the SGA and the column store. So actually, Exadata is an excellent platform for database and memory, and there are, again, some special features we have that are only enabled with Exadata. So, but in your particular case, the marketing aside, probably it has to do with parallelism and the data distribution across column stores. So with that, I will continue on, so I don't want to get too far afield, but excellent question. And that does come up with folks because it is a little different than the row store behavior with either rack or even single instance databases. So let me switch now again. So I've got my new share. We're gonna go over to my VirtualBox and take a look at, well, if I hit share, there we go. And let's go, and we're gonna, so I have, hopefully you guys can see that. Is that big enough, Tech, do you think, or do I need to make the font bigger?
Looks good to me.
It's okay. So if anybody has a complaint, let me know. I can try to make it a little bit bigger. But notice I have 21C, so 21.4 database. So that allows us to take advantage then of 21C features, of which in-memory hybrid scans is one of them. And what I've got is, I've got a cheat sheet. So I'm gonna cut and paste my commands rather than trying to type them in, because if I don't wanna, so that way I won't fumble and cause a bunch of time spent you watching me type. So populated. So let's take a look at what we currently have populated. And I actually have all of the star schema benchmark tables populated just because it's part of one of the demos I do. But what we're really worried or focusing on is the line order table. And then actually, I'm just going to highlight, notice that number there, because as we get later in the demo, we'll go back and compare that, because we're going to, part of the reason for in-memory hybrid scans, excluding columns to save space. And I'll show you just kind of an example of the kind of space savings that you could achieve, and then still being able to query those, query the line order table, those columns, assuming they're in a production list, and getting good performance. So that's our lead in there. And then there's another query that I don't know if people are all that aware of. It's not anything magical per se, but it's a way to display the columns and whether they've been excluded or not. And so this is basically just a picture of $IM column level, which is another $V view. Remember, it's an Oracle database, so we have $V views along with our hints and execution plans and all the rest. And so I've populated all I did literally was an alter table line order in memory. And so I did that ahead of time only so that we wouldn't have to watch population occur twice. We're gonna have to watch it once, but I didn't want to endure the time a second time. So the point of this query is just to show you that all of the objects are populated or enabled for in memory with their default in-memory compression level, which is memcompress for query load. So and this will become more important in the second part of our demo. And then I have a query that we'll go ahead and run. So fully populated. So this is just a normal in-memory query, basically. I have it here. So let me go through this. It ran fast, which we would expect. So the query, which is what I showed you in the slide, is just simply summing the revenue from line order based on a particular date, with quantity and ship mode. I mainly did that just to be able to focus down the demonstration into a certain smaller subset of data, which is one of the great things about database and memory is the ability, and we again talked about this as well, to push filter predicates into the scan to make it really, really fast. And so in this particular case, it ran less than a second. Notice table access in memory full. So we access the line order table in memory. And we'll continue on with the demo to show you some other features of in-memory hybrid scans. And then, as I said, we see in the predicate information that we've actually pushed our filter predicates into in-memory. And that's what that line in the predicate information section tells us. Again, some of this we've gone over in the past. I'm going to keep saying that only because if you're curious, maybe haven't seen some of our other sessions, I'd encourage you to go back and look at this, because we have talked about this in much more detail than we're going to spend today talking about it. But bottom line is we did just a normal in-memory query, but we also took up 3.2 gigabytes of space. So now, can we do better than that? And that's kind of basically the point. And then our statistics, I included those here, not particularly interesting. The only interesting part, well, we'll come back to that. So now let's go ahead and we're going to alter the table to be no in memory. And then we're going to run the alter table command, and we're going to exclude a whole boatload of columns. And then I'm just gonna, because I don't want to wait, I'm impatient. So I'm gonna, whoops, just kick off, I'll make sure the population gets going. A couple ways to do this, dbms in memory admin, or when you can start population, or just accessing the data. Since I have priority high, but this just makes sure that we kick off population as quickly as possible. That'll take a second. Notice though that in the columns that I excluded, I did not include order date, quantity, or shipment, because those are in our where clause, and those still have to be populated. If you exclude columns that are in the where clause of your analytic queries, then all bets are off. We're not going to be able to use in-memory hybrid scans. We're going to go to the row store for that data, or for that object, I guess is a better way to put it. Okay, so then I'm going to run, and we've talked about this a little bit, but in the background, hopefully population is screaming along. And we notice that our bytes not populated is non-zero, but population has started for our status. And if I hit it again, notice it's going down. And just for fun, since we're gonna have to wait for this, if we were to do a top, we can see in the background, and that's just a takeaway, asynchronous in the background, population occurs. You can see our W processes there spinning away, chewing up CPU, reformatting the data into columnar format and putting them in IMCs in the column store. Again, all things we've reviewed in the past, but kind of just fun to take a look at since we are waiting for things to go. It's going pretty fast. We're almost done. This is why I didn't make you endure the full size previously. I just did this ahead of time. You can do this for yourself in our Live Labs environment. Unfortunately, Live Labs, I'm working on an update to the Live Labs environment, but currently it is 19C. So if you want to try this with 21C for yourself, and you can use either the base level feature in your environment, and again, we've done some office hour sessions so that you don't trip the licensing, because database in memory is an option, so you do have to license it. Or you can download developer days and in a VirtualBox, very similar to what I've got here, and experiment with it in 21C there as well on your own laptop if you have enough memory. And it doesn't really take that much memory. An 8 GB laptop will run developer days fine, and mine's a little bit bigger than that, but it's the same basic idea. We're almost done. This is the in-memory part. We do have to get the data in memory. One of the things, folks, I'll just mention it, we'll bring up is in the row store, it's really kind of a onesie twosie thing about database blocks. And you initially query an object, we might bring in just a select number of database blocks into the column store. So the very first query will be slower than subsequent queries, which is very similar to database in memory, except with database in memory, we're populating the entire object. So it does take longer. You have to factor that in to your application architecture so that if you restart the instance, that you know that until that data is fully populated, you're not going to get the maximum benefit of database in memory. Just things to bring up. All right, so we're fully populated. Now check that out. So we have now, since we excluded those columns, we're only using 1.5 GB of memory, as opposed to, I go way back, way in the back in the past, we used 3.2 GB. So there's the motivation for excluding columns. Again, you can also use compression, but for excluding columns to maximize your in-memory footprint. So now what happens if we run our query? And actually, I'll do one more query too. We'll go back and run our column level just so that we can see if maybe you at some point may be curious, did I exclude columns? So now I've run that same $im column level query, again for the line order table. Now notice that some of the columns, these two guys, and then these guys are all no in memory. So we've excluded almost probably half the columns in the table, and the point being to save space, which we've saved basically half the space that it required when it was fully populated to be, when we've excluded columns, we've gained considerable amount of extra space in the column store. Now the question is, if you're depending on your application, your objects, are you querying those columns in analytic queries? If you are, you probably don't want to exclude them. But if you're if either never or very rarely querying those columns, then excluding can be an excellent way to save space. So hopefully I got that point across. Anything to add, Tech? I don't want to leave you out of all this and do all the talking.
Sounds good.
I'll put you on the spot. I did the same thing to Roger in the last session. So, and feel free to jump in. So now let's run our query again. Remember, it's doing the sum of the LO revenue, which right here, where I run it, we've excluded. So it actually came back pretty fast. Let's make this a little wider. There we go. So it's a little slower, although to be honest, on my machine, it's kind of a wash. And granted, it's not a huge data set. Your mileage will vary when you're using much larger tables, but the point is, it still ran screaming fast, same exact query. And notice that now in the execution plan, we see table access in memory full hybrid. So the optimizer figured out when it parsed the query that some of the columns weren't in this particular case, LO revenue, weren't in the query. So it transitioned to a different execution plan. But it tells you that. So you know that you did a hybrid, in-memory hybrid scan for this particular query. And again, because we didn't populate the LO revenue column in the column store. And then we can see that we actually did not physical reads, but if you notice our session logical reads, we had to actually go pick up some blocks from the row store in order to satisfy the revenue column. And what happens is we actually run the column or run the query and apply all the filter predicates. So we're only having to go find the LO revenue column values for the rows that pass the return of the query of the filter predicate. So we don't have to scan the entire line order table in the row store to get the data. We only have to look at the particular columns that passed our filter predicate for our query. So again, another speed up. Anything else you want to add there, Tech, to help explain that? I don't know if I did a good enough job on that or not.
Yeah, I was looking at a question from the chat actually.
Okay.
So, but I think the important thing is we save space, and the query elapsed time is pretty much the same as with or without hybrid, right?
Yeah, and obviously your mileage will vary depending on, notice we're only getting 749 rows back based on our filter predicates, as opposed to the table, which has like 59 million rows in it. And I have one more test to show what happens if we did have to run it no in memory. So say we were on 19C or earlier, we'd have to actually go to the row store. And so what happens in that case, whoops, my cheat sheet is being covered. So I noticed we had some non-in-memory scan questions. And I forgot to put, well, it's here. On R. That's the risk of doing, maybe it was this. Well, anyways, we'll just do this is the SQL we were running. We'll just put our no in-memory hint right in here and rerun it just to show apples to apples. Make sure we're highlighting the benefit of the feature. Best laid plans, and it still didn't quite work out. For the interest of full disclosure, there we go. And that is the query we were running. So, and you can tell it definitely runs longer than, which is what would happen for this query if we had excluded the LO order date, quantity, ship mode columns, which I just didn't want to have to go through another population because we're already taking a while. But notice again, same kind of query, but table access felt full, so we're no in memory, and it takes 21 seconds because now we don't have the joins in that other query. So sorry about that. Bottom line is we can maintain almost, in a lot of cases, in-memory speed, but save tremendous amount of space in the column store by just picking up the projection columns. So I think that's what I wanted to cover. And it looks like we have some questions. I don't know, you're busy typing answers, Tech. Do you want to discuss some of them since we do have some time?
Yeah, so I think what you are talking about, Andy, kind of goes nicely with the last question. The question is, how do we actually, like what happens under the covers? And that's exactly right? We use the in-memory column store to run the filters. And as you could imagine, the column store filtering is a lot faster than the row store filtering because of the way we encode data, right? We have dictionary encoding and a lot of really great techniques that are great for fast filtering. And at the end of that filtering process, we do generate row IDs like you speculated, right? a list of row IDs that says, here are the passing rows. And that's how we fetch the relevant projection columns from the row store. So that's spot on. But
so
I think
since we have row IDs in the column store, because we have to be able to reassociate column values together, right, as we return data to the query. So then we know the row ID of the particular rows or column values. I was going to say row, column values, right? So then we can just go pick those up from the buffer cache. That's basically the gist of that, right?
Correct.
Yeah.
Yeah. So the one thing to point out, and I think Andy mentioned this, right? The selectivity of the predicates matter. With very good selectivity, right? In this case, you're just selecting a very small number of rows. You're going to see an amazing speed up for very little DRAM, right? It's like disproportional, right? You're using a lot less DRAM for pretty much the same speed up. But if your selectivity is such that you end up projecting a lot of rows, then the speed up becomes less, right? And over time, of course, there will be cases where just say all rows pass, then you might be doing extra work, right? Because you are now going to the column store plus the row store for all the rows. So that's one thing to just keep in mind, right? The selectivity really matters if to get the speed up that you desire.
Right. So if we're going to look at all 59 million rows in the line order table, this isn't going to help us. It may even, and there's a tipping point based on cost that the optimizer will just punt and say we're going to go full table scan. But
Right.
But in this case, in analytic queries where we're doing aggregations and we're doing filtering, because we're purposely not going to return 59 million rows, we're only going to look at 749. And even though we're looking at the 59 million column values in the column store, remember we're filtering those out as we do the scan. That's this stuff down here tells us, so that we only have to project the 749 LO revenue column values, and that's much faster. And then we can go get those from the row store, and it's very, very fast. So yeah, so there is a cost, like everything else in life. There, this isn't magic; it's not free, and so. Analytic queries typically are aggregating and filtering data. And so that's why in-memory hybrid scans typically makes a lot of sense for queries that are analytic in nature. And then we can get the other big benefit of that tremendously reduced memory footprint in the column store. What about this other question, in-memory force? This is not a in-memory hybrid scans question. This was a because I don't think, as I recall, not everybody can see the question. And so just if they can't, then we can go ahead and talk about this. This is one of those, this was similar to the base level feature in that we backported it to 19.8. So it's, do you want to read the question or do you want me to do it?
Go for it, Andy.
So it says, as you mentioned, the in-memory force parameter equals cell memory will keep objects in flash, but is a licensed option. We run in the in-memory advisor to see an estimate of the benefit. Will the advisor output only consider DRAM, the non-licensed 16 gigabytes? I'm gonna have to go through and explain a little bit of this. Or will also evaluate the impact of cell memory column storage too. And if this cell memory column or store, the license option is only for production, or even it has to be licensed for dev test environments too, in case someone wants to test behavior before first using it in production. So wow. All right, so let's back up the boat here a little bit. So in 21C, we introduced the base level feature, which allows you to allocate up to 16 gigabytes of column store without having to license the database and memory option. In addition to that, and we backported that to 19.8 and higher. In addition to that, on Exadata, we support not only column store in DRAM and the SGA in the in-memory area, but we also support then objects that haven't been populated in the column store in Flash if they've been smart scanned on Exadata platform. So that's only an Exadata feature. It's not a non-Exadata feature. And what we did is we have some customers who are memory constrained. They maybe even on Exadata, they've done consolidation. They don't have a lot of memory, and they have the case where they want to use the flash, but they don't want to allocate the column store in SGA because they just don't have the memory for it. So what we did is we created another option to the in-memory force parameter called cell level. Actually, I think it's cell level, not cell memory. And what that allows then is that enables database in memory, licensed, it's not part of the base level feature, to allocate just use flash for in-memory columnar formats for objects that have been smart scanned, and not allocate any column store, because by default, you have to enable in memory in order to be able to use the cell memory also. Hopefully that makes sense. So the question, I think, centers around the confusion between, does the base level, because the parameter in memory force is the same base level versus cell memory or cell level. And I might have to go look that up because maybe I don't have that right.
Yeah,
but I think it's
cell memory level.
Okay, cell memory level. Okay, and this is basically to avoid having to allocate any memory in the in-memory area in the SGA, but that has nothing to do with the base level features. So the base level feature does not allow you to use cell memory level to test out. So all of that then is part of the database in memory option. Test and dev environments, to be honest, I don't recall whether you trip the in-memory database option license, and I think you do, but the answer that I'll give you, since I tend to not try to get focused on licensing issues, because that's really your account team can answer that question. But my assumption would be that if you're going to trial or do a POC to see, hey, does it make sense on our Exadata environment to use cell memory with database in memory and not allocate SGA, you can get the account team can set it up so that you can test that out without having to pay for the license if you decide that for some reason. And typically we get, so I usually tell folks you can expect about a 10x performance improvement using database in memory in the column store. And we usually see about 4 to 5x performance improvement with cell memory over not having database in memory formats in the smart flash cache. So you still should see performance benefit, but it isn't going to be as good as DRAM. It isn't. It's not. There's physics involved here. We have to make IO calls into flash. It's not as efficient as actually having that data in memory in DRAM. And that was a long-winded answer. I hope that got you the answer you wanted. And I think the biggest confusion there is confusing the base level feature and being able to use cell memory with the base level feature, and that's not possible. That's not allowed.
Yeah. So to the point about the in-memory advisor, the in-memory advisor only considers the DRAM portion.
Oh,
right? It
missed that
doesn't
completely.
go and poke around on the cell side.
Right.
But just to add to Andy's answer, I think the hybrid scans is one way to put your hottest data in DRAM, right? That's your most precious commodity. And the Exadata cell flash cache is humongous, right? That's where you can put your next tier of data. So your hottest tier in DRAM, then the next hottest would be in flash cache, and hopefully that should fit possibly your entire data set, right? Yeah. And that's all automated. You don't have to do anything, right? Everything, there's some caching mechanism that makes sure your hottest stuff would be in the flash cache. And hopefully you get full columnar, right? You either get columnar on the DRAM side or columnar on the flash cache side.
Right. So you effectively get terabytes of columnar storage, and I think that's when I described that's the best way to think of it but you're basically multi-tiered. So you have a tier in DRAM, which is for your most business critical data that you want the best performance for. And we would be remiss, I think, if we didn't mention automatic in memory, which can help you manage the database can manage the objects that get the biggest bang for the buck in the DRAM or the column store, and then objects that won't fit, don't get identified as being the highest priority, will then be populated in the column store or in the cell memory in the smart flash cache, and you still get the advantages of database memory columnar formats, pushdowns, and all of the benefits there. And then data that and essentially it's very hard to run out of flash cache on Exadata. So you can pretty much expect if you're an Exadata customer with database and memory, all of your analytic data is going to either be in DRAM or in flash, because the Exadatas have terabytes of flash available, and that's all automatically managed, as Tech mentioned, so that you don't have to do anything with that portion. So AIM working in the column store in memory area in the SGA, and then the rest of that data being brought into the flash cache gives you, and that's actually another big benefit of Exadata, gives you that ability to manage and essentially automatically manage terabytes of columnar storage for your analytic requirements for your applications. Not to be salesy, but I mean, we've worked pretty hard with the product to get all that to work properly, and AIM is kind of one of the big key strategies to making this fully automatic. And 21C AIM, and we talked about that, is actually much different than prior releases, where we have now the ability to essentially enable all of your objects to be in memory, and then only populate basically the ones that are going to get the biggest bang for the buck, to make it essentially fully automatic. That's kind of the goal, anyways. All right. Well, we still wind up using them almost all the time. We'll hang out a little bit more. If you have any other questions, be more than happy to answer them. Give you a few minutes, and then Tech, thank you very much for helping out. I really appreciate it, answering questions and giving a little more insight into how the feature works under the covers. That's I think people really like to hear that.
Yeah, I'm happy to be part of this. Feel free to invite me in the future.
Okay. Well, because you might not know that, we'll just briefly, we talked about this before, but I was thinking about doing another one because I want to explore parallelism a little bit more with database and memory. So I wanted to do another AskTOM session, and another feature that's near and dear to your heart, in-memory dynamic scans, is a key component of that parallelism strategy. And so I very well will probably invite you back to talk about that in a little bit more detail. So so now you're on the hook.
Yes, and I put it on the record in the Q&A that in-memory dynamic scans is the answer to automatic parallelism for in-memory, right?
Yes.
So definitely, it's the goal is really to make things as automated as possible, right? And dynamic scans is the other aspect to it, right? Andy mentioned automatic in-memory that decides what gets into the column store, but dynamic scans is just a preview. It just decides what CPU resources on the DB side that we can automatically use, right, to enhance the query, right, without user intervention. Yeah.
We had one other question. It says, does Exadata Smart Scan by default use parallelism behind the scenes automatically, even if no parallelism is used in the query? The answer is yes. So you'll always get parallelism across the storage servers, because there's going to be more than one storage server on your Exadata machine. And in talking to some of the other the Exadata guys, essentially the rule of thumb is whatever your DOP is times the number of storage servers. It's kind of the parallelism that's going to occur in the storage server framework. So you'll always get at least parallelism across the different storage servers. And then if you've enabled parallel query, you'll get even higher levels of parallelism, which is one of the reasons in our best practices in our implementation guide, I always say when you're comparing Exadata performance, you need to look at the overall parallelism and make it a fair fight. Because if you're running serial queries against the column store, but then running parallel queries in essence against the storage servers, it's not a fair fight. So, but that's essentially the way that works. And with that, I think we're pretty close. I think we'll go ahead and sign off. Thank you, Tech, for joining me. Thank you for everybody for the questions. Hopefully this was useful. I will post the recording, and what I've been doing is posting the the text version of the queries I ran along with the presentation on our GitHub account, on my GitHub account, which is in the link on the resources page on the blog, which I should probably close with. If I would be remiss if I didn't. So let me new share. I'll go back to teach it all dog new tricks. And where can you get more information? And I mentioned previous Ask Tom sessions. Bottom line is all of the links that I've mentioned are on our resources page. If you haven't seen our blog, it's blogs.oracle.com/memory. And then there's a resources page, which I try to keep the link to it up on the high part of the page. It's also in the hamburger bar up at the top for the index if you want to pull down and get it. But there's all the links to this Ask Tom sessions, the GitHub repository where I try to put scripts and then previous Ask Tom information. And so hopefully there's enough information there. If not, you can always email me and ask me, and I'll get you whatever, try to get you whatever you need. So with that, I think we'll go ahead and conclude our session today. Again, thank you very much, Tech, for joining me, and everybody for attending.